Hi. So let's continue our series of binary search with our next question, that is entering zeros in factorials. Let's see what the question says. It says, given an integer n, find the number of positive integers whose factorial ends with n zeros. That means if you are given n equals to 1, you have to find how many numbers are there whose factorial has 1 zeros. Like output is 5. 5 factorial has 1 0. 6 factorial has 1 0. 7 factorial has 1 0 at the end. And 8 factorial has 1 0. 9 factorial has 1 0. Now when you will calculate 10 factorial, what will happen? You are going to actually multiply 10 with 9 factorial. So 9 factorial already have 1 0. If you multiply 10, 10 will give you another 0 at the end. So it will become 2 zeros. So for 1 0, the answer is lies between 5 to 9. These all has 1 0 at the end. So before solving this question, we have to understand how we can identify some x factorial. um, yes, so some x factorial has how many zeros, how many zeros, how we can identify that. First of all, what we can do, that we can calculate our factorial and we can see that. So it will take order of x time if the number is x. But we always have a shortcut. We has a shortcut idea, that is dividing it by 5. So how we can do that? Let's take an example of 100 factorial. How many zeros we have in 100 factorial? For calculating that, in number system we have a way, that is keep dividing 100 by 5, you will get 20. Now they get divide it again until you get 1 or 0. 4. Now again 4 by 5, it will be 0 if we do integer division. Okay, so how many zeros we have in the 100 factorial, you will get by adding these all. Okay, so 20 and 4, that is 24. That many number of zeros we have. Okay, so we can find it out using log 5. Okay, that's the idea of finding number of trading zeros for a given number n. Okay, or given number x actually. Now the question says the total number of number of trading zeros is n. So what you can do, you can go for a linear search. How, like you can search how many trading zeros 1 factorial has, how many trading zeros 2 factorial has, all the way till the time you get a number where we have n trailing zeros. Okay, some x factorial, it, let's say it may have n trailing zeros. Okay, so now at the first, let's look at some examples. From 1 factorial to 4 factorial, we have, let's say this is number of zeros, 0. 5 factorial to 9 factorial, it have 1 zeros at the end. 10 factorial, when you multiply 10 with 9 factorial, 10 factorial will give you 1 0, and it will continue until 14. So it will have 2 zeros. Now when you have 15 factorial, what will happen? 15 factorial will provide a factor of 5, okay, which will continue till 19 factorial, and it will result 3 zeros. A 20 will come, and again it will provide a factor of 1 more 5, which will result another 0, so it will be 4. So you may it may seem that we are having every number, like for 1, for 1 we have 5 to 9, like for n zeros our range somewhere is 5 into n plus 5, 5 into 5n plus 5, isn't it? Actually less than 5n plus 5, so 5n plus 4 till this number. Now, but this is not the case. If you go one more step ahead, if you see 25 factorial to 29 factorial, here there will not be 5 zeros. Here will be how many zeros? Number of zeros will be like 25 factorial. So 25 is providing 25 equals to 5 into 5. It is providing 2 5, isn't it? 2 factors of 5 in my multiplication result. So it will result 2 zeros, not 1 zeros. It will 25 will give 2 more zeros. So in this range we will have 6 number of zeros. So if the given n is 5, how many number has 5 zeros at the end? Our answer will be simply 0. If it is asking another n equals to 1 or 2 or 3 or 4 or 6, how many numbers are there? 20 to 24. Always the count of number is 5. Always your count of number is 5. Answer is 5. Okay. So that's all. This is the concept I want to say. So for some n your answer will be 0. For some n your answer will be 5. Now here you can see that example was given for n equals to 5. If we want to find the number of number where uh, number of trailing zeros is 5, that answer will be 0. Okay. So then again, how we can approach our question? Okay, let's come here one more time. If n equals to given something, like let's say 5, we will start searching from 0, let's say 1, and we will go till 5 into n, because 5 into n can be a possible answer. Why I am saying possible answer, not sure answer? Because for this it's okay. 5 in, if 1 n is 1, 5 factorial is answer. For 2 it's okay, 5 into 2. For 3, 5 into 3. For 4, 5 into 4. For 5, when n will be 5, then obviously we will not get any answer. But for n equals to 6, 5 into 6, 30. But 30 is not an answer. 30 factorial is not an answer. But our answer will lie before 30. 0 to 30. So we can search our answer from 1 to 5 into n. Okay. The 5 into n, for the first time 5 into n itself will be answer, and for later after 25 your answer will lie before 5 into n. Now how you can find your answer? You can find your answer by linear search. Obviously for 1 you will see, for 2, for that, and one by one. Another way can be apply binary search, because your numbers are sorted, number line you are doing it on the number line, so that is sorted and you are searching in this range. Now let's say for you get one mid, you have to check how many zeros are there, sorry, how many numbers are there which has mid number of zeros. How you can check for a number how many zeros, trailing zeros it has? Using this method. Using this method. Okay. So if we talk about our algorithm, that is int, sorry, low will be 0, high will be 5 into n. Okay, we will have our answer By default, let it be -1. No, let it be 0 by default. Okay. So while low is less than equals to high, if no, first let's count zeros. Int zeros, count zeros. For which number? For mid, but we don't have mid, so we have to calculate our mid. So int mid equals to low plus high by 2. Now if number of zeros is equals to n, then this is the answer. Okay, this can be an answer. That means there exists a number where number of trailing zeros is n. So how many number will be present whose number of trailing zeros is n? Obviously 5, because our answer can be 5 or 0, nothing else. We have seen why, because after 5 number you will always get a factor of 5. So number of zeros is going to increase. Now the question is, it will increase by 1 or it will increase by 2. That's the question, but obviously number of zeros will increase. Sorry, not 0, we are returning 5 because we got a number. Else if number of zeros we are getting currently is less than n, so that means we need more number of zeros. So we will update our low to mid plus 1. We want to bigger our number, we want a bigger number, and at the else case a high can be updated as mid minus 1. That's all. And at the end what we can do, we can return 0. Just we haven't got any number, we don't need this variable. Okay, now count zeros we will implement it directly. Now let's discuss about complexity. Obviously L and H are there and we are dividing it by 2. So complexity is log base 2 in the range of 5n, 0 to 5n, that means n, constant multiplication, into, at the each case we are calling this function count zeros, which will calculate number of zeros mid factorial has. So how you can calculate that? By dividing it by 5. So it will take again log 5, write it here in. Okay, so this is our complexity of the program. Let's see what are the required complexity here. Just log n, same. Okay, so let's implement our code. So we will have a low with 1 and a high with n, sorry, 5 into n. Okay, while low is less than equals to high, we can calculate our mid, that is low plus high by 2, and then we will count zeros, count zeros of mid. Now if these zeros equals to n, number of required zeros, then return 5. Else if number of zeros is less than n, that means I have to increase my current number of zeros, so we can update our low to mid plus 1. Else case we can update our high to mid minus 1. And at the end, if we haven't find any number whose number of zeros is n, so we can return 0. Now we have to build count zeros, int count zeros. for a number n. Let's say zeros, number of zeros is equals to 0. Okay, so now let's go like this. And okay, so while we have n, we can add zeros to n by 5, and so n by 5 will be our answer, and we will update n equals to n by 5. Okay, okay, so and at the end we can return number of zeros. Let's compile and run this. Okay, submit it. Yeah, so this is our solution. Now let me know, do you like the question or not. So that's all for today. Thank you guys.